Hello, everyone. Welcome to our webinar, the last one in 2020, the last Connection Wednesday this year. And this time, the topic is the 3 most common traps in connection design. So quite interesting, I guess. Before we start, let me just mention one practical thing. We use the GoToWebinar platform, and you are muted by default, but of course you can place your questions, if you have any, into a questions panel in the GoToWebinar platform. We will try to go through them during the webinar and answer them directly. And if we do not have enough time for that, we will send you the answer via email after the webinar. So let me introduce my colleague Emilio, who is a structural analysis and design consultant in Construsoft Spain. So hello, Emilio, how are you?
Hello, Yana. Hello, everybody.
Yeah, and my name is Jana Kadirova. I'm a product engineer at StatiCa. And today we prepared 3 very common, or maybe most common, traps and 3 different examples. Hopefully it will be very useful for you as well. And these problems came from StatiCa Campus, which is some like educational platform where you can get some knowledge about modeling an StatiCa connection. And Emilio, who is in charge of the campus, finds these 3 things very common, and he would like to show you what is a correct way of dealing with these problems. So without further delay, let's have a look at the first one. So the question 1 will be about bolts and composed steel cross sections, because sometimes if we use a composed steel cross section and we want to bolt it, we will find some bolt error in the scene, although it looks quite okay and we cannot see any problem. So please, Emilio, show us the correct approach to that.
Okay, thank you, Yana. Okay,
I will
let's
pass
go
you the
on.
presenter.
Yes. Please, if you can confirm that you can see my screen.
Yes, I can see it.
Okay, let's move to the StatiCa model. Well, as Yana said, when we have some composed cross section, we have to take an additional care about the how to model the connection properly. In this case, here I have a prepared model in which I have this column and this composed beam. And okay, I will try to reproduce the normal workflow with the software. So if I want to join the beam to the column, I probably will create a new operation, and I'll try to looking for some template that can be adjust for this connection. Well, here we have the thin plate operation, and it is perfectly valid. So here I have prepared the operation, perfectly configured. Here I have for the top flange. I do the same for the bottom flange, and then for the web. Okay, it looks nice. Finally, I add some stiffeners, and here I have the model. Well, when we try to calculate, we obtain this error. Bolts are too close to the plate edge or outside of the connection of the connected plate. Well, why is appearing this error? What is happening? If we take a deeper look at the thin plate operations, we have defined the member B, the beam, it's okay, and member part top flange 1. However, the composed clock sections usually has several top flange or several webs or something similar. So in this case, I have two top flange. Top flange 1, here I can see the default name, and in this case bottom flange 2 because it's the same section, just rotated. So top flange 1 and bottom flange 2. The problem with this thin plate operation is because we are setting the member part as top flange 1, so some bolts, in particular these bolts, are outside of the top flange 1. So this is the problem. So we have several ways to deal with these problems. There are several ways, and I would like to focus on two main workflows. The first one could be okay. I want to keep the thin plate operation, but I need to remove the bolts and make something with those bolts. So I modify the connection type to weld and set in the member no weld, and then I can add some manual bolt operations. Here I have it. So in the first case, I have the bolt operation, the bolt row for the top flange 1, and here for this other flange. You can see in a better way the brown highlighted plates are the plates that the bolts are connecting. So in this case is perfectly valid. For the bottom flange, I would like to show you another alternative way, because if I deactivate the thin plate operation, when I create from scratch this thin plate operation, I have an additional problem. And this is because when I set the member part bottom flange 1, for example, the reference point to set the dimensions or the size of the plate is related with this plate, with the bottom flange. So it's a little bit tricky to set the correct dimensions if I need to center the plate. So I need to calculate the width, make some subtractions. So I would like to show you an alternative way with a manual plate operation, this one, stiffening plate. Here I have prepared again the plate. It is the same, but in this case, I set the size of the plate and I relate this plate with the column. In this case, bottom flange and type rib. So I just need to set the position. It is easier. And here I have the same plate. Then the same workflow. I can add some manual bolt operations for each flange, and here I have it. Okay, so now when I try to run the analysis, there is no error. The analysis ran successfully, but I always recommend you that you have to check, of course, the results. And in this case, it's very interesting when we check the equivalent stress and we move through the connections. We have some surprise here. What is happening here? Why this plate has no holes, and of course, why we are not obtaining the same stress distribution because the connection is perfectly symmetric. This is because the same. This is because I am using a thin plate operation with member part web 2, but our beam has 2 webs. So these bolts, when I move to the rear part, I can see that the bolts are not connecting the first web of this beam. So again, the same. I can change the connection type to weld, no weld, and then I can add some manual bolts operations. And of course, it is important that in these manual bolts operations, we need to use items count 3. because each bolt need to cross 3 plates or 3 entities. Okay, in this case, when we run the analysis, we will obtain the expected results. We move to equivalent stress. Okay, and here I have it. It is perfectly connected now. Okay, and I think it is everything for this first example.
Maybe I can ask you one more thing to that. If you could just sum up. What's the difference between using some specific operation like fin plate and the general one like stiffening plate, or why or when can we use one and when the other?
Okay, it is a very interesting and complex question because as you can see, it is the same. There is no difference, and both methods, both templates or manual plates operation are perfectly valid. So the question is, for each case, it is not a common or a general rule. For each case, in some cases, it's better to use a template, or in this particular case, the fin plate operation. And in other case, it is better to use a manual plate. It is because for some cases, the manual plate will be faster, and in other cases, the template will be faster. In this case that I am presenting you, the fin plate operations, for example, I don't use it for the flanges because the reference point is not aligned with the center of the beam. But for example, in the case of the beam web, the fin plate operation is perfectly valid because the web the beam are symmetric. So the plate by default appears in the center of the beam, so we can use it perfectly. There is no problem.
Yeah. So can we say that in cases where it is just for the specific operation, the configuration is easy, so it means one web, one plate, we can use the specific operation because the bolt connects only 2 plates. But once we have either composed cross sections, when you want to connect the fin plate to 2 different plates, it's better to for example, to use the general bolts so that each bolt group connects only 2 specific plates. Otherwise, you will get an error. And you can, of course, combine it. Okay,
yes.
so thank you very much. And we can have a look at the second example,
Yes,
which
of course.
will deal with such nice connection. There is a stub, as you can see, between the column and the horizontal beam. And in this task, users want to connect the stub with a splice to the beam. And because they are very creative, they have different approaches, but not all of them are quite correct. So we can have a look at it now.
Yes, of course. In this case, the connection is a little bit more complicated. So, because I would like to focus on the splice connection, I will delete the bracings and I just work with this part of the connection, the splice. If we move to the idea StatiCa, here I have again my empty model. Just I have just the column and beam. And as Jana said, there are several approaches to how to model these connections, and it's very common the error that I would like to show you. So, how to start to model the connection, or what is the most common way to model this connection? We set the main members, and then I need to add some operations to connect them. So I go to the operation template, and again, I'm looking for some template that I would like to use. this case, the stub could be an option, but there is a problem because it looks like I have to use the plate-to-plate connection type. And then here I have a splice template. It looks very nice, but I will need to add some additional member because we need 2 members to connect with this splice plate. So let's go. We can make a work plane just to cut the beam. And then the next step is to add an additional member here to make the stub. Okay, I cut this additional member with a column, and then I need to cut again the member with a work plane, as I did with this one. And surprise, there is a problem. It looks like I cannot choose the end of the member that I would like to cut. So there is a problem with this. Okay, there is no problem. I can do this. So I delete this cut, and in some cases, very funny cases, the user says, okay, I need to modify the length of the member. If I go to the member properties, I am not able to modify the length, but I remember in code setup, there is a nice field to modify the default length. So maybe I can do this. I can set 1.2 on, oh, okay, I got it. I have my beam perfectly cut. Okay, so I need just to apply the splice operation. I switch on, I select member 5. Oh, here I have it. Perfect. I go to run the analysis. Okay, I will check, here I have it. I will check the stress distribution. Oh, there is something wrong here. I can increase the form shape. Oh, can you see? Here I have 2 beams. Here I have the beam duplicated. Why? Because the default length in code setup is applied just from the last operation in the model. So if I apply this splice operation in member 5, the length of member 5 starts not from here, from the cut, but from the splice. So if I take a look at transparency view, here I can see that my beam has a length increase due to the splice operation. So this is not a right method to implement this design. Well, there is another common approach, and probably is my favorite one because it's a very smart approach, but is a very wrong approach. In this case, the user says, okay, the stub operation looks like is to plate connect the beams, but probably if I modify something in the stub operation, I will be able to get the connection. So, okay, let's try it. Here I have the stub, I activate it, okay. Well, the first approach, if I switch the thickness to 0, maybe I will delete the plate, but not, because the 0 size is a default size in IDEA StatiCa. So this is not a properly way. Okay, for example, 5. Another approach is, okay, I will play with the dimensions. I will select rectangle and then set 0, 0, 0, 0. Okay, there is no plate. Oh, perfect, I got it. Okay, let's try to make the cut of this stub with a column, and then we activate the splice and set the member to this stub operation. Perfect. We would like to run the analysis again. Oh, error. The plate area is too small. Okay, why? Because despite we have set the dimensions for the stub plate as 000, internally IDEA has this plate. And when we run the analysis, the software tries to mess this 000 plate. So we obtain an error because there is no way, there is not possible. IDEA is not able to mesh this plate. So this is very smart solution, but it's not a right solution. So I would like to present you, I don't know why, but it is a little bit unknown operation that the user usually does not use, and it is called the stiffening member. This one is an additional or manual operation in which we can introduce cross sections, not plates. So let me switch off these proposals, and then I would like to start with the work plane to cut the beam, and then I would like to add this stiffening member. Okay, what is the difference between the stiffening member and the member? The problem with the member is for IDEA StatiCa, the member is an entity that I would like to apply the internal forces because it's an structural member, and in the global model, this element continues. So we have internal forces, and IDEA StatiCa expects that we apply internal forces. So when the member is the geometrical type end, we are able to cut one end, but not the other, because in the other, the structure needs to continue. When we use a geometrical type continuous, this is this case, we are not able to cut any end because the structure continues in both ends. So this is the difference. In the case of a stiffening member, it is an auxiliary member. In this case, it's a stub, but it could be an auxiliary angle or whatever you want. So in this case, this stiffening member is not a structural member, it's just an auxiliary member, so I am able to cut or modify both ends. So in this case, I activate the first cut with a plane, with the work plane, it's okay, and then the second cut with the column. And finally, I apply the splice, I select related to SM1, and here I have it. When I run the analysis, there is no error with the mesh. And if I take a look at the results, the equivalent stress, there is no error with duplicated beams or something similar.
Yeah. Nice. So we can see that we need to have a creativity, but still to check our results where it's correct. And yeah, sometimes there are more ways how to reach the target model, but sometimes not all of them are correct. So yeah, and we need to know some basic stuff like the difference between member and stiffening member and so on. So thanks. And we can move to the third example.
Yes.
This one is a very interesting connection, quite complex one, with a plate imported from DXF, as it has very unusual shape. Well, it's like a star shape. So what could be the problems when importing such plate from DXF? And in this case, there will be a mesh topology error due to that import. So let's have a look at it.
Okay, let's move to the IDEA StatiCa model. Here I have my connections. Of course, it is a most complex connection, so I would like to focus just on this part, on the complex plate. That of course we are not able to model it directly in IDEA StatiCa, so we need to import from a DXF file. Okay, I did it. I load my save from a DXF file, and then when I try to run the analysis, the software is generating the mesh, the finite element mesh. And here I have a mesh generation error. Bad topology in SP5 is this imported plate. Okay, why appears this error? This is because there is something in the plate that is not allowing to StatiCa to mesh the topology. If I deactivate this connection, this connecting plate, I can see that I have imported the plate also with the bolt holes. This is not correct. Why? Because in StatiCa, when we use operations which implies bolt, the bolt creates his own hole. So if I have a topology with the holes, the bolt generates an additional hole, and there is something redundant, duplicate. So there is a problem with the topology in the plate. And how to fix it is very easy. Just to select the plate, go again to the DXF file import. Here I have the file. Okay, first I need to check the units. It is very important. And then select the plate that I would like to import. Here I have an additional plate for this connection. In this case, I select the contour, select outline, and I have not to load the openings. So I click OK. I update the plate, and then when I turn on the operation, here I have the connection properly modeled. If you are interested, I can show you at the end the connections calculated, but in this case it's a little complex and it takes several seconds or maybe 1-2 minutes. So I would like to show you an additional issue with the importing plates from DXF. Here I have a secondary model in which I have delete or switch off the connection of these bracings, and I would like to show you two methods to import or to create these connecting plates. The first one is okay. I have a DXF file with the topology of the connecting plate, so I would like to use it. Okay, I create a new manual operation. I change the shape to polygon, DXF, plates to import, open, millimeters, and then I select the contour, outline, click OK. It is perfectly valid, but there is a problem that my imported plate is located in the global coordinate system, and I need to move it. Of course, I can to move through the coordinates and rotations. It is a little bit hard, but I can use a shortcut playing with the origin of this plane, of this plate. I switch to join from join to plate because I would like to relate the imported plate with this previous plate. So I select the plate SP5 and then the type Doppler and rear. Okay, perfect. Here I have it. I said no weld because it is not welded. And then I need to set the coordinates X and Y and the rotation. So more or less, it is more or less easy, but we have to play a little bit with the coordinate to set the right position. Okay, here I have it. Once I have the plate, I need to make a cut of this bracing element with the imported plate and select surface. Okay, perfect. And finally, we can add some manual bolt, 2 items, first one, second one, and the position. Okay, perfect. Here I have it. Okay, this is the one method. But I would like to show you that the DXF import is not always the best way to model the connection. So I would like to show you an alternative way to model this connecting plate. I can use this operation. It looks like it's always generating the connecting plate and the gasket, but it is not true, because I can select, in this case, the member M10, and then connected to, instead of new plate, I can select a 16 plate and then select this one. Okay, I play a little bit with the parameters. For example, position 0, okay, the thickness 12, cut plate no, notch member. Okay, can you see? It is almost done. I just need to play with the size of the plate. In this case, I have here. Okay, and finally, I need to add this rounded part, this curved part. To do this, I would like to show you a little bit the editor. The arc operation applied to edge 2, opposite, and then the elevation is the radius, the half of the width of this plate, in this case. Okay, and then the bolt, by default, here I have it. Okay, similar ways, perfectly valid ways to do the same. But this connecting plate, in this case, in this particular case, has a small advantage, because if when I run the analysis, I need to modify the thickness of the connecting plate, or this meeting plate. For example, I would like to force 30. If we take a look at this method, in this case with a DXF, we see that we need to move proportionally we need to apply an offset for this connection bracing, in order to center with the plate. However, the CPL, the connecting plate operation, automatically moves this bracing to adjust in the middle of the plate. So in this particular case, maybe it's better, or it's easier to use the CPL instead of manual plate with DXF importation. Okay, and well, some additional comments you can see here. I have another stiffening member. There is not a member because I need to cut both ends. I don't know if you want to comment something.
Yeah, so maybe we can see that in this case, the specific operation was more convenient to the general one, which is the opposite what we saw in your first example. So it's up to the case, and the more experienced you are, the faster you find out which is the best way to model the connection. And maybe yes. I would ask one thing more. During yes. the export or import of plate from the XF, users very often have some problems, some errors with that import. Can you mention those two reasons, most common reasons? Why is it so?
Yes, the first one I have comment during the workflow is to check the units, because this is the first problem. Check the units, and then there is another common issue, and it is because sometimes in our DXF file we have modeled the geometry with a polyline, or maybe it's a block. So it is a very recommended practice to explode the polyline or the block before to import and get individual lines. It's better. And then there is another funny topic related with this. And in some cases, we have received some consultant because the DXF file looks like it is everything okay. There are individual lines, the units are perfectly defined. But when we try to import in IDEA StatiCa, we obtain an error, or we are not able to import a shape. It is because the DXF file from the top view is perfectly defined, but when we move to the top view, from the top view to the side view, we rotate the model, we can see that there are several levels or several elevations for each line. So there is not a close contour to generate the plate. So it is important to take care about it.
Yeah. Okay. So thank you very much, Emilio. I will take the presenter now, and because I want to show you a few more things. So as I mentioned in the beginning, those 3 examples were very often questioned in IDEA StatiCa Campus, and I would like to make you a show presentation of the campus itself. Emilio is an author of this very well worked course, Theory and Practice of Steel Connection Design using IDEA StatiCa. And if you don't know the campus, let me just show where you can find it and how it looks inside. So first, I would recommend to go to our webpage, ideastatica.com. And if you roll just to the very bottom, you will find a link to e-learning and certification. And this will bring you to the web page dedicated to IDEA StatiCa Campus and to our online certification course. And you can, of course, read what is it about, what the former students say about it. And to get into the campus, please use the Sign Up button. And after you fill your credentials, you will get a new account in Campus and you can log in. So let me just log in into my profile. And this is the dashboard of the campus. And this is the first view, what you will see inside. And of course, there are 3 tutorial videos which will lead you through the campus itself, how to find things here, how to work with it, and how to orientate. And the content itself starts under this button, and you can see there are different chapters. The course itself starts with an introduction of the component-based finite element method, and then it goes from the simpler topics like introduction, geometry, and modeling to some more complicated and more advanced ones. So there is a chapter about load settings, stress and strain analysis and its results, stiffness analysis, then the other types of analysis like buckling and capacity design and so on. There is a chapter about creating reports and documentation, and of course the BIM workflow in IDEA StatiCa connection and many more additional materials. So let's have a look into one of these chapters. Let's say maybe the load settings. So in each chapter, you will see different sections. In this case, there are 2 of them. And in each of them, you will have a nice video explaining and commenting the work. And of course, you can also have it printed in a PDF file, so all the comments and all the explanations are here as well. In the end of each, or in most of the chapters, you will see an assessment. In some cases, it's a quiz, and in other cases, there are some modeling tasks. And the examples Emilio presented are just the ones from the campus. And if you are successful, you will get a certification in the end. What's very useful, and I would like to emphasize, is our tutoring forum, which is another channel where you can educate yourself. You can, of course, place your question if you have any trouble, or if you are interested in something that you didn't find in the chapter, you can place your question here, and you can also go through the questions asked before. So it's another way how to find different important things. And you can see that Emilio is taking care of this forum very well. If you want to try our campus, you can get a trial. So after you get your credentials, you are free to enter the free trial, and the content is just the same, only first 3 chapters are open to you. The other ones will be locked. So in those first 3 chapters, you will get an impression how the course is composed, how the materials look like. So please feel free to sign up and give a try to our campus. And that's all from the content today. Maybe we can have a look at few questions. We got some of them. There was a question about the recording, which will be, of course, available, and also about the stiffening member, which we answered, I guess, was the difference between member and stiffening member. Maybe, yeah, there's a question, is the certification for free? So maybe I can show you it's not for free. There's a free trial. The price of the full price is 490 euros. For students, we have a special discount, and I would recommend to speak to your local reseller if he or she is able to provide you some discount. So please ask your local reseller, and you can also use this chatter button in the bottom of the page to get in touch with him or her. And maybe one interesting question. So how difficult is to get the certificate? So maybe I will ask Emilio to answer that question, because he is the author of that.
Okay. Well, for me it's easy, of course, but I think that there are 2 groups or type of students. A completely beginner with the software. In this case, maybe the course is a little bit hard, but it is hard because the idea behind the course is to move from the most basic level to the most advanced. So we talk about the different analysis, a little bit theory or background behind this analysis. So maybe it's a little bit hard. For advanced students, it is also interesting because there are several advanced topics, and I think it would be interesting for them. Of course, it is not difficult because you have forum questions. You can talk with other students, and of course, I usually help the students. So the cases that I have show you are common questions from students. They write me, okay, Emilio, I'm trying to complete the assessment number 5, but when I try to run the analysis, I obtain this error, and I don't know why. And I usually reply them, and I think it is more or less easy. But for the beginners, they have to work a little bit more.
Yeah, but it's also a proof that they will learn something there, of course. So
yes.
Yeah, so don't worry, you will get help if you need it. And there are some more practical questions about the course. I would suggest that you enter the platform, and there's Idea StatiCa course fact sheet. It's a PDF where all the practical info is listed. So there's a description and the learning objectives that you have to fulfill, the content. So for any other details, please visit the web page, and you can also drop us an email if you want to know something which is not there. Okay, so we are in the end of our webinar. Thank you very much for your attendance. We really appreciate it, not only today, but during the whole year 2020, which was quite unusual. This recording will be available within 2 days on our web page and also on our YouTube channel. You can get a free trial of Idea StatiCa on our webpage, and you can also get a free trial of the certification course. And thank you, Emilio, for your work. Thank you very much for your time, and let's hope the next year will be a little bit less crazy, and maybe we will meet personally eventually in 2021. So all the best from Idea StatiCa team, and thank you very much.
Thank you very much, Anna. See you next year.
Goodbye.
Goodbye.